Good morning. I'm just getting started here on our review for logs, part 2. We're going to have our test coming up this week that you can do to help improve your grade. So here goes. Let's see if my pen is working. Hooray, it is. All right, so it starts at number 10 because this was it was pieced together with part 1. So part 2 starts at 10. Sorry about the weird numbering, but that's where we're starting. So starting with number 10, we're supposed to solve the equation. There are a variety of ways to do this, but our goal, of course, is to get that x by itself. So I'm going to work on the thing that's kind of furthest from x, and that's this times 6 times or times 6. So to undo that or get rid of it, I'm going to divide both sides by 6. That gives me this cancels out. I have 18 to the 10x minus 2. On the right-hand side, 24 divided by 6, I get 4. Then at this point, I would try to check if my 18 and my 4 could be rewritten with the same base, meaning like, is there a base with an exponent that will give me 18? Not really. That would be 2 times 9, but there's not really a way to make it, excuse me, a base with an exponent, so I can't get them to match. So then my next thing is to try logs. So I could rewrite this. I could log both sides, or I could rewrite it as a log equation. Actually, I'm going to show you both versions. Okay, so on this first one, I'm going to rewrite it as a log equation. So that means I'm going to take my base, always begin with the base, and I'm going to say log base 18. Then I do the swirly. So log base 18 of 4 equals 10x minus 2. So that's one version. The other version is you could just literally log both sides. So you would use a common log. So it would be log base 10, and then you'd have 18 to the 10x minus 2 equals, and then log this side as well. Again, common base, so base 10. All right, back to the one on the left. If I'm doing the one on the left, I'm solving for x. I'm going to probably add 2 to both sides, but before I do that, because my left-hand side is a little messy, if you're using a graphing calculator, if you have one at home, then you can probably do a base 18, excuse me. However, if you are not, if you're using Desmos, Desmos requires you to do change of base. So that would mean a common base of 10. So I have log, excuse me, my voice is just not very agreeable. Give me 1 second. Excuse me. Okay. So we have log 4 and then log 18. That's our change of base formula that we used last test for part 1. So the base number always goes in the bottom, and now it's a common log. All right, then on the right-hand side, we still have 10x minus 2. At that point, you could calculate this out if you wanted, log 4 divided by log 18. That would give you 0.4796. And just for a standard for this review, I'm rounding everything to the 4th decimal place. So you'll see that as we go along. And then on the right-hand side, of course, we still have 10x minus 2. Then I would add my 2 to both sides. And so that gives me 2.4796 equals 10x, and then divide both sides by 10. And that ends up giving me, when I calculate that out, I get, and again, rounding to only 4 decimal places, I get x equals 0.2480. That's a rounded answer. Okay, then the other version I didn't finish solving. So when I log both sides on this one, I would need to take care of this power up here. I would need to plug. So put that in front. So I have 10x minus 2, and it goes all together like that. And then log 18 equals my log 4. Because this is multiplication, I would undo it by dividing both sides by log 18. And that gives me 10x minus 2 equals log 4. Actually, if I calculate that out. Log 4 divided by log 18, we already have that calculation in our problem to the left. We have 0.4796, and you can see right there that these two steps are the same. You're at the same place, they just look a little different. So either way is fine, and your answer here at the bottom, x equals 0.2480. And there we go. Let me just box this up and we'll go on to the next one. All right, so number 11, you have e to the 4x equals 25. Again, two different ways to do this one. You could log both sides or you could write it into a log equation. I'm going to show both. So if you look at this and you're like, all right, I can swirly this into a log equation. Because the base is e, we would use a natural log, base e, that's the same e from the problem, and then swirly around. So 25 equals 4x. So that would be if you chose to rewrite it as a log equation. So swirly. The other version is you could literally log both sides. Again, because the base is e, we would natural log both sides. So natural log the e from the problem. All I'm doing is putting a natural log in front right now. So both sides like so. And then you would solve from there. If you're doing the log both sides version, you're going to need to plug. So that'll maybe help you figure out how to go from there. It's very similar to the last one. If you stick with the rewriting it as a log equation from here, this natural log base e of 25 is something you can put in your calculator. So all you would have to do is actually divide both sides by 4. So you'd have natural log 25 divided by 4 equals x. When you calculate that out, you get 0.8047. And I'll go ahead and show you this side as well. I mentioned you would plug. So put that 4x in front. And remember, this whole thing goes together. It's times the natural log e equals natural log 25. And then, hey, I didn't even notice, hey, what is the base for a natural log? Oh, it's base e. So just kidding, these really cancel out to equal 1. The natural log and the base cancel out there. So you wouldn't even have to plug. Oh, dear, dear. So you could, or if you caught that sooner, you wouldn't even have to plug. Go back to this. Because you are putting in a natural log with its own base e, because we logged both sides, this actually cancels. You have 4x equals natural log 25, and then divide by 4. Either way, if you continued what I started before, it would work the same. And again, you get 0.8047. It's a little faster if you realize it sooner. All right, so that is our answer here. Let's continue on to the next one. All right, so we have a log plus a log, big complicated equation. When I see two logs like this, my first thing is I want to change that plus into multiplication, but I can't on this one because I have different bases. So then I'm going to look at those bases and see if there's anything I can do. And this is going to go back to my question. What does the log ask? Remember, log means what power or what exponent. So if I look at this, I can't really answer that for this part. I can't do it for the x because it's an unknown. Excuse me. But if I look at the second one, the second set, log base 5 of 5, this is asking me 5 to what power equals 5? I can answer that. The answer to that is 1. So if I simplify that second expression part to 1, I have log base 7 of x plus 1 equals 2. Now I only have one log in my problem, so I'm going to try to get that by itself to get to my x. So I'm going to subtract 1. Be careful here that you don't get confused and think that it's x plus 1 that's in the log. The plus 1 was a separate expression. So subtract 1 from both sides. We have log base 7 of x equals 1. Then I can very quickly swirly this. 7 is going to be my base. So 7 to the first equals x. And actually, that's your answer. You're done. X equals 7. Awesome. Well, let's continue on to number 13. This one, I see those two logs again, so I'm going to see if I can condense. This time I'm looking at subtraction. So I would be changing to division. And if I look, my bases do in fact match, so I can do that. Condense it to log base 8 of 2x squared over 2 equals my 4. So my first part over my second. And when I do that, those 2's are actually going to cancel out. So I have log base 8 of x squared equals 4. Then you have some options about how to do this one. You could do some plugging if you want. I would probably just go straight to writing it as an exponential. So switching back to exponents. So this would be 8 as my base to the 4th power equals x squared. Then 8 to the 4th, when I multiply that out, is 4,096. And then to get that by itself, I would square root both sides. And I get plus or minus. Remember, if you put a square root into your problem, you put in the plus or minus. So this is actually 64 equals x. Couple of quick notes here. If you're doing this on Desmos, when you go to put in an exponent, the buttons you're going to push are Shift 6. Above the 6 is the little symbol that looks like this, like a little up arrow. That's what you're looking for to give you an exponent. And for the square root, the cheater way to do that on Desmos is you're going to type in the letters SQRT, and it should immediately turn into your square root symbol. So there's a couple quick things there, but the answer you're looking for is plus or minus 64. Specifically, when you get a negative as an answer, you probably want to double check. You should check all of them, but that you don't have an extraneous solution. So if I go back and try to plug in positive or negative 64, I'm going to be okay because it's squared immediately. It's x squared. So you're going to square out that negative. You won't have a problem, but definitely should check. All right, so that was our answer. Let's go on to the next one, number 14. So number 14, again, I see those matching bases, 2 logs, same bases, and I see subtraction. So I'm probably going to want to do division here. Just for the heads up, that's not the only way to do this problem. If you follow the log question on the second expression, you can do 4 to what power is 2 if you happen to be able to figure that out. If not, just do the condense. So log base 4. I'm going to have x squared minus 1 over 2 equals 1. At that point, it looks super messy, but it's actually not too bad. Take your base. You can always rewrite this as an exponential. You can always go back and forth between logs and exponents. So this would be 4 to the 1st power equals x squared minus 1 over 2. At that point, I'm going to rewrite this just for the sake of people looking at it after the fact. I'm going to probably multiply both sides by 2 to try to get rid of that fraction. So I have 8 equals x squared minus 1. At this point, you have kind of 2 different options on how to solve. You could solve by moving the 8 to the right, so you have 0. So that would look like this. Subtract 8 from both sides. You would get, I'm going to move up to the top here. You get 0 equals x squared minus 9. That's one version. The other version is you could actually do the reverse of that. You could have said, oh, just kidding. I really want to solve and get x by itself. So you had 8 equals x squared minus 1. You could have actually added 1 to both sides, and you would get 9 equals x squared. So either version of this will work. If you do the 0 version, I'm going to move my little arrow here. It's kind of in the way. If you do the solving it or setting it equal to 0, the reason we do that is to try to factor. And this is actually difference of squares. So this factors really nicely. This would be x plus 3 and x minus 3. And then we would set each part equal to 0. So x plus 3 equals 0, x minus 3 equals 0. And then we get x equals negative 3 and positive 3. If you solve the other one, you square root both sides, and you get x equals plus or minus 3. So same answer either way. So it doesn't matter which way you do it. I'm just going to draw a little star here so we get what's going on. So it doesn't matter which way you do it. Do go back and double check. If you put in a -3, you're going to end up squaring it, so it'll be positive. You're okay. No extraneous solution. So our final answer is -3 and +3. All right, number 15. Again, seeing that same kind of pattern, I have matching logs, matching bases. Those are base E. And then I see subtraction again, so I'm going to be doing division. Remember, if it's addition, you're going to be doing multiplication. But this one's subtraction, so we're going to divide. I'm going to condense this to natural log. I'm going to write in the base E, and I have 2x over 10 equals 2. Part of my reason for doing that is as I jump into the next step, I'm going to swirly to get rid of that natural log. So I have e squared, so base for the exponent, and then 2x divided by 10. This, to get to the x, I'm going to, because my goal is to solve for x, I'm going to multiply both sides by 10. Actually, I'm going to do that in a separate step here. So people that look at this afterwards can see it a little bit easier. Let me save a little bit of room here. So I have, that was e squared equals 2x divided by 10. So I have, I'm going to multiply both sides by 10. So I get 10e squared equals, those are going to cancel out. So I have 2x, then divide by 2. And you could have done it faster if you wanted to, multiplying by the reciprocal or something, but this works just fine. And I get, on the right-hand side, I'm going to have x. On the left-hand side, when I do that calculation, switch to my notes here, I get 36.9453. And again, I rounded to 4 decimal places. And that's it. All right, let's go to, that was number 15. So we're almost done, only 2 to go. Let's go to number 16. This one, we only have 1 log. So we've had a couple equations where we had 2 logs. This one only has 1. So when our variable is in the log expression, our goal is to get that log expression by itself so that we can get x by itself. So in this case, I have 2 options. I could take this 5 in front and I could unplug it. But if I look at that, that means I have to do x plus 7 to the 5th power, which is essentially x plus 7, x plus 7, x plus 7, x plus 7. You can see this is not going to be what I don't want to have to multiply that out 100 million times. So I'm going to get rid of all this. I don't want to unplug it because that's going to be messy. Instead, this is 5 times log. I can get rid of it by doing division. Now, you could have done it the other way where you did plug it. It's just a very, very messy problem. I'm sorry, unplug it. Anyways, very messy problem. So here I'm going to cancel those out. So I have log base 8, x plus 7. And then I have on the right-hand side, 10 divided by 5 is 2. Then if I simplify this, I did simplify it, I'm sorry. Then at this point, I would probably turn it into an exponential. So I would take my base and I would switch it around. So I have 8 squared equals x plus 7. That turns it into a fairly easy problem by swirling and changing it to an exponential. Okay, so then I have 64 equals x plus 7. Subtract 7 from both sides, and I get 57 equals x, and that's my answer. All right, last one. Here I see 2 logs back in my problem, but this time I have a single log on each side. When we have just 1 log on each side, we can essentially cancel them out. You may recall that from the semester. It's the same concept that we use if I say something like 3 squared equals 3 to the 5x minus 1. I just made that up. But what do we know about the 2 and the 5x minus 1? Those have to be equal because both of them are, if it's an equation, if they're set equal, then those exponents have to be the same. It's the same concept in a different, showing it in a different way. So using that concept, the log expressions have to be equal to each other because the logs have the same base. So those have to be equal. All right, so basically that means I'm doing 4x equals 10 minus 3x to solve this. And again, you can only do that if those bases match. All right, so then to solve it, this is a fairly easy problem. I'm going to add 3x to both sides. I get 7x equals 10. And then divide both sides by 7, and I get x equals 10 over 7. This one I didn't bother reducing it or putting it into a decimal because it's a pretty straightforward fraction. And that completes our work. Nice job, guys. I'll see you soon.